Hi, in this tutorial we're going to be modeling a nitrous oxide bottle. So let's get started with a new part. And from here we're going to start a sketch on the right plane. So I'm going to click on right plane, come up to sketch, and click on sketch here. And from here we're going to first come down to the drop down under line, and we're going to select center line. Drag the center line to the origin, click on the origin, and now bring that line up to about here. And we want to work in inches, so we're going to come down to our units and we're going to select inch pound seconds. And from here I'm going to edit my sketch, bring out a smart dimension, and set this to be, let's say, 16 inches just for right now. And this is really going to be our center line, so it's just going to be a reference line for our rotation. And from here I'm going to add a couple more sketches. I'm going to start with the line tool, click on the origin again, and we're going to drag this out to about a 7-inch diameter. So this is going to be 7 divided by 2. And you're going to see that it updates to be 3.5 inches. That being said, I'm going to drag out another line, and I'm going to make this one 12 inches, so 1 foot. And from here, I'm going to create an arc starting on this line, coming out, and I'm going to click on this line and this arc, and I'm going to create a tangent relation here. So when I select both of these, this window will pop up with two relations, and the one I want to select is tangent because I want to make them tangent to each other. So this is going to be, as I mentioned, 12 inches. And that being said, what I can do at this point is I can click on this line and drag the arc to connect with the center line. And from here I can come back and click on line again, click on this point, drag it out. Then I'm going to click on it once more, and I'm going to click on for construction here to make it a construction line, and hit OK. And from here I can click on this arc and this line, and I can make them tangent to each other. So now we have our arc finished, and from here I can click on the arc, and I'm actually going to make this for construction. I'm also going to click on this bottom line here, and I'm going to make this for construction as well. So as you can see, we're kind of building out dimensions for our rotation. Some of them are for reference, other lines are really just for rotation, but we're kind of building out a structure and framework that's fully dimensioned and currently fully defined. So the next thing we want to do is we want to drag out an arc. And I'm going to click on this point again, and I'm going to click on the for construction arc. And when I set it in place, you can see that the point moves along the arc. So that's what we want. That makes it very easy to control. And from here I can come over and click a line, and I want to make a few more lines here. Now the first thing we want to do is set a dimension for this line to be 1 inch, and we want this line to be 0.675. And what I'm going to do is I'm going to click on this point, and I'm going to click on the origin. And when I select both of those points, I can come over here to my relations and make it vertical. And when I do that, you're going to see that it updates accordingly, and the 2 points are now in alignment with each other, and that's what we want. So from here what we want to do is make this center line longer. We want it to go past our sketch. So I'm going to set this to be 19 inches. And I'm also going to create one last arc before I create the line that connects all these sketches. So I'm going to click on this point, and I'm also going to select right here. And from here, I can come over and click center line. And I can click on this dotted line and this arc, and I can make them tangent to each other. And from here, I can set a dimension from the origin to this point. And I want this to be 3/4 of an inch. I'm going to hit OK. And you can see that it's dimensioned accordingly. And the reason why I made this line here, this construction line, is because if I connect a construction line to this point here and I make them tangent to each other, then as long as this line is horizontal, it's always going to make this arc perfectly tangent to it in a direction we want. So that's a very useful tool to use. That being said, we're going to come over and connect the top point and bottom point, which is right now here. And you can see that we now have a closed profile. So I'm going to get out of the sketch, and now is a good time to save. Just going to save this part. And from here, what we want to do is we want to create a revolution. So I'm going to come over to Features, and I'm going to click on the Revolved Boss Base. So I'm going to click on anywhere in my sketch just to start the feature. And the first thing that we're going to select is the axis of revolution. That's the axis in which your closed profile is rotated around. So I'm going to click on this axis. And you're going to see that Solidworks is smart enough to understand that I have a closed profile and that I want to use it in my revolution. So selected contours down here at the bottom is where you would select your profile. See, I can select it. And now it's fully selected. And when I hit OK, you're going to see that Solidworks builds it as a solid part. So from here, we want to add 2 fillets. I'm going to come over here under Features to click on my fillet feature. And I'm going to select this edge, as well as this edge along the bottom. And we're going to set this to be 0.25. And we're going to hit OK. And from here, we can actually maybe bump this up a little bit. The thing about fillets when it comes to air canisters and bottles and things that hold a lot of pressure vessels, is if you have sharp corners, the pressure will build up in that sharp edge, and that sharp edge becomes a weak point where you can have a break, and that's where the gas or the liquid that's under pressure can come out. We want to be sure that this fillet is large enough, so I'm actually going to bump it up from 1/4 inch to 0.275. And I'm going to hit OK, and it's going to rebuild. So a little bit larger. And so from here, what we want to do is we want to shell our part. So I'm going to come up to Shell under my Features tab, click on it, and we're going to click on this face because that's a face that we want to remove. And you're going to see what that looks like in a moment. But first, we're going to set our parameter to be 3 millimeters. 3 millimeters is the thickness of the wall that we want within our shell. So I'm going to hit OK, and you're going to see that Solidworks has taken 3 millimeters and converted it to inches, so 0.118 inches. And I'm going to hit OK. And you're going to see that our part is now empty. So I can come here and click on this section view, and you can see that it's a fully empty vessel right now. So let's exit out of that. I'm going to save it once more. Always important to save as you go along. And so from here, one thing we want to do before we continue is we want to right click on material and hit edit material, because we know that our pressure vessel here, our canister, is aluminum. I'm going to come down to aluminum alloys, click on the plus sign, and that's going to bring up all these different materials. And the material that we want to use is a 6061 alloy, and I'm going to hit apply. So I'm going to select it, hit apply, and we can just hit close at this point. And you can now see that the color has changed a little bit. And just for fun, we can come over to mass properties, and it's going to give us the mass, 4.24 pounds estimate from what we have right now. So that's great. And from here, what we want to do is we want to create a sketch here on this face. So I'm going to come over to sketch, start a sketch, and the origin is origin of our sketch is going to be automatically in the center here, because that's where our origin is of our part, because we started our sketch, our first sketch for the Revolve, right on the origin. Very important. So I'm going to come over to circle, click on circle, select the midpoint here, and I want to drag this out and kind of place it, because I want to set a smart dimension for this circle to be 1.035 inches, and I'm going to hit OK. So you can see it's kind of like an offset from this edge right here. We just created this one circle. And what the circle is going to allow us to do is it's going to allow us to use our Helix and Spiral tool. That's what we want to go with next. So I'm going to exit out of the sketch. And the next thing we want to do in this part is create a tapped hole here so that we can attach fittings to our canister. So where we want to go from here is come back to our Features tab and come over here to where it says Curves. Click on Curves and select the Helix and Spiral tool. So it's going to ask us for a sketch that we want to use, and I'm going to click on this sketch here. You're going to see that we get an initial preview of the Helix and Spiral settings that are already set here in the menu. What we want to do is set our defined by to be the height and pitch. And from here, we want to be sure that we're working with a constant pitch, and our height we want to be 0.8 inches. And when you click here in the feature control menu, you're going to see that it updates accordingly. And what we want our pitch to be is we want it to be 14 threads per inch. So because of the fact that we're doing 14 threads per inch, I can just type in 1 divided by 14. And you're going to see that Solidworks automatically updates this value to be of that. And what we're doing here when creating a nitrous oxide can is we're going to be creating a thread for a CGA 660. That's the pipe standard. Now we're not going to be making it exactly, but we will be working with the 1.035 inch diameter circle and the 14 thread per inch requirement for this example. From here, let's click on reverse direction. And the next thing you're going to notice, if I come here to the top, is that our start angle is actually starting here at the bottom. You can see the little gray arrow. We don't want it to start at the bottom. We want our starting angle to be in alignment with our plane. So if I come over here to look at our planes, you could see that the front plane and the right plane are coming at 90 degrees to each other, as we would expect. And you could see that the start angle is intersecting through the right plane. So that being said, I can keep that in mind. And so we can actually leave our start angle at 0 because we know that we have a plane passing through it. And that's going to be very important for our next step. So from here, I'm just going to hit OK. And one last note, I want to make sure no one makes this mistake, is be sure that this is unselected, taper helix. If you do have this selected, you're going to run into problems because your taper is going to have an angle to it. You're going to have a tapered thread, and that's not going to work very well when you want to create a plane and when you want to do your addition of the thread and all that sort of thing. So be sure that this is unselected. Let's hit OK. And from here, what we want to do is we want to go to our right plane. And let's look at our right plane. It intersects this line. So the end of this line is right where the right plane. What that means is I can create a sketch on the right plane for the profile of our tapped hole. So let's start a sketch on the right plane. And within this sketch, we're going to make it a little easier for ourselves. Let's look directly at the right plane. And what we want to do is come over here to section view. And we're going to select the right plane here from this section 1 option. And you're going to see that that cuts the part for us. So that section view is going to help us with our design process. Let's start by creating a line. So I'm going to come up to line, click on it, and I'm going to drag out a vertical line. And then I'm also going to drag out an angled line, a short line, and I'm going to come back and click on this point again. And from here, let's set a smart dimension between these two lines to have an angle of 60 degrees from each other. And you're going to see that my sketch gets a little bit crimped. That's okay. I can drag down on this point to kind of move my sketch around, and I can kind of drag it around until I have my general shape again. And I want to add a little bit more structure. I want to be sure that these midpoints of these two lines, that they align with each other. So I'm going to click on center line, click on this line, drag it out. Now I'm going to click on this line and click on this point. And when I select those two, I can come and click on midpoint. And that's going to set them to be together. So from here, we want to add a couple more dimensions. Let's set a dimension here on this line to be 0.0089. We can also set a dimension here to be 0.046. And that's going to be the height of the tooth. So what we can do from here is we can drag this around. You can see that it's very easy to do so. And we want to place this on this top line of our sketch. So I'm going to place it right here. And you can see that I can move it back and forth, but that's not what we want. We want this to be constrained. Now it can move left and right because it's constrained to our line here at the top of our part. There's your reference right there, the top of the part. But we really want it to be a little bit more controlled. So what I can do is I can click Smart Dimension and click on this line. And because of the fact that we built our part around the bounds of the origin, I can click on the origin and set a dimension between that previous line and the origin. And I can keep lowering this dimension until it's where I want it to be. Now for this example, I'm going to make this, say, 0.56. And you're going to see that at 0.56, the sketch is over the bounds of the cylinder. And what that means is that when we create our helix, it's going to, we're not going to have any problems with a gap between our thread and the part. We definitely don't want that to happen. So for this example, we're just going to leave it at that. And with our profile created here and our spiral, the next thing we want to do is we want to create a 3D sketch. And that 3D sketch is going to bring out our helix so that we can use it to select for our next feature. So the next thing to do is let's come up to our features, click on features, and we're going to select the swept boss base. Now we're not cutting into the material, we're actually adding our thread. So we're going to make sure to select swept boss base, and we're going to click on our path, our profile. So we're going to click on this profile here that we've created, and it should be a closed shape. And see, we can now select our spiral because it's a 3D sketch. And you can see that it's updated to show you the preview. So you can see that it's coming down a little bit further than we want. We want to be sure that our thread is not passing the point of the flat here. So what we can do is we can hit OK, and you can see that it's updated accordingly, but we need to change a couple parameters here to be sure that we're not creating anything that's impossible to manufacture. And you can actually see that there's a gap here between this wall and the thread. Now we can't have that. So I'm going to go back to our helix and spiral, and I'm going to click on Edit Feature. And I'm going to dial this back as much as I need to until the point that we're not having any more problems. So that's the height. I can set this to be 0.7, and you're going to see that it's going to bring it back. It could be 7.5. Maybe that's a good happy medium. And you're going to see that it ends right at the point before it turns into a fillet, at least in this cross section. So we just want to go back and let's dial it back a little bit more just to be safe. And that should be good. So you can see that we've actually created a thread here inside our neck, but you can see that this would not actually be possible to create. We couldn't have a thread that sticks out of the part, and we definitely will have trouble threading a part onto something that starts like this. So for those reasons, we're going to need to do one more feature. From here, what we want to do is we want to create a cut, and the cut is going to get rid of this top part that we don't want of our thread. So let's start a sketch on this face, and let's click on this outer edge and convert entities, and we can go back to features, extruded cut, and if we cut upwards, we can completely remove that little edge. And the great thing about this feature is you can see that we've actually created a sharp here within our thread, which is going to allow us to attach a threaded screw or a cap or whatever we want to add to our thread here. So that being said, that's our canister design. The last addition we'll make in this video is the addition of some text on the cylindrical surface of the canister. The way to do that is we're going to come to the right plane, and we're going to create an offset surface from this right plane. So I'm going to come up here to reference geometry, and I'm going to click on plane, and I'm going to offset this just up to the point where we're outside of the part limits. This is good enough here. So we're going to hit OK, and I'm going to start a sketch on this plane, and I'm going to draw a center line that comes across the part, and that center line is going to be horizontal. And from here I can click here where it says text, and if I select this line that I made, under curves, which is the first thing that comes up and the first thing that you select, I can now type in text and add that text to the top of the line. So oftentimes these canisters have a bunch of markings, letters, numbers, warnings maybe. So I'm going to add a couple of warnings here and maybe a couple more random numbers and some spacing, just to kind of show as an example what can be done. Once we have our lettering where we want it, I can actually click here on center align and center align all the text that I've typed in into this text window. I'm actually going to make this a little bit larger so that it's easier to see. So you can see I have my curve. That's the line that I first selected. I have my text box here, and I also have my center align, left align, right align, the same way that you would have in, say, Microsoft Word or that sort of thing. So that being said, we're going to make one last addition. I can click here under Use Document Font and deselect this. And now I can actually set the tracking as well as the thickness or width of the letters. We're going to come down here to Font, and you're going to see the power that Solidworks has in the ways that you can type in whatever font you'd like that's installed on your computer. And oftentimes with applications like this, it definitely helps to use a thick lettering, because this is a text that needs to be placed on the surface of the part. So here I'm going to change from units to points, and doing so is going to allow me to change my font size using points. And when I hit OK, we're going to get a nice preview, and I can get rid of a couple things here just to be sure that we're within the limits of the surface area here. So we're actually going to come back, and just as easily as we changed it before, we can change the text to 18 font if we want, and I can get rid of a couple more things here. So we're going to leave it at that. And one other thing you can do is you can move your line and align it to the ends of your part. And if you do so, because of the fact that the text is aligned, it's always going to come to the middle, because that's what we set in our text feature. So with this being finished the way it is, I'm actually going to move the line up, and you can see that the text moves with the line. Now, as I mentioned before, this is a cylindrical surface, and the next feature that we're going to use only works with cylindrical surfaces. It's the wrap feature. So I'm going to bring this as close as I can to the top, because that's the location where I want this to be. And I can come up here to Insert, and under Features, I can come down to Wrap. So I'm going to click on Wrap. And I want to select Deboss because I want to cut into the material. And so the first thing that it's asking me for is the surface that we're going to use for the wrap sketch. Now, what this is the surface that you're going to be projecting onto. So I'm going to select the cylinder, and you can see that the text has wrapped along the face of the cylinder. Now, over here, there's an option for depth. For the depth, we're only going to make it, say, 0.010 of an inch. That's often around the distance that you would see for the depth of it. And emboss would mean that the text is coming out at you. Obviously, deboss is the opposite. So we're going to hit OK. And you're going to see that the text has updated accordingly.